Hello, Mr. Lin here. We're starting into a new topic today. We finished the ecology unit and we are now embarking on biochemistry. So a good place to start for biochemistry is atomic structure. Hopefully some of this will be review for you. And then of course we'll take it to some new deeper levels of understanding. So what is the atom? The atom is the smallest unit of matter that retains the identity of that substance. If I split an atom, then I'm no longer that element. So atoms, elements. Atoms are composed of two regions, the nucleus and the electron cloud. An important idea here is the electron cloud is mostly empty space. Therefore, the nucleus contains most of the mass and the density of the atom. In the nucleus, we have subatomic particles that live there, namely protons and neutrons. And you need to know, protons are positively charged subatomic particles that have a mass of 1. Neutrons are neutral, so they carry no electric charge, and they do have mass, however, of 1 as well. In the electron cloud, obviously the electrons exist here, and electrons have a negative electric charge. Relatively no mass. They do have a tiny bit of mass, but it's almost insignificant. So how do these particles interact? Well, protons and neutrons are compacted in this positively charged nucleus, and the negative electrons are small and they sort of orbit or circle around the nucleus. And generally speaking, with the electrical charge of the atom will be electrically neutral. And if that's the case, the number of protons is going to equal the number of electrons. So one of the things I'm going to expect that you're able to do is to identify the numbers of protons, neutrons, and electrons in the first 18 elements. So, for example, if I'm looking at an element on the periodic table, atomic number 20, we could know that that element has 20 protons and it also has 20 electrons. To find neutrons, we have to look at the mass number. And we'll look at some examples of in a second video that I'll post this week. So how do we know this? Like I said, the atomic number is the number of protons. So hydrogen has an atomic number of 1, therefore it has 1 proton. And the atomic number is not something you'll need to memorize. You simply look it up on the periodic table that I will share with you. You can also find a periodic table in your biology textbook in the appendix area. Carbon has an atomic number of 6. Therefore, we can say carbon has 6 protons, and also that carbon has 6 electrons. How do we know the number of subatomic particles, aka the neutrons? Well, the neutrons is indicated by the mass number of the specific element on the periodic table. The mass number is the number of protons added to the number of neutrons, because each of those particles has mass. So hydrogen, for example, can have a mass of 3. Since it has 1 proton, it must have 2 neutrons present for that isotope of hydrogen. This equation is pretty useful. I would recommend writing this one down. The number of neutrons is the mass number minus the atomic number. Where do we get these numbers? We look on the periodic table. I'll share with you a periodic table in just a moment. Let's look at lithium as an example. Lithium has a mass number of 7 and an atomic number of 3. So we would use this equation. We would subtract 7 minus 3 to get 4, and my number of neutrons is 4 for lithium. Neon. Sorry. Neon has a mass number of 20, an atomic number of 10. Protons would have to equal 10 because I know the atomic number. Neutrons would be mass number 20 minus 10 is 10. What about the electrons? I already told you that that's equal to the number of protons. So let's take a look at these examples. Chlorine has a mass number of 35 and an atomic number of 17. Question here might be, how many protons, neutrons, and electrons are there? Well, protons and electrons are the same because they equal the atomic number. How do we get 18? We take 35 minus 17. Now let's take a look at the Bohr model of the atom. The Bohr model is technically an incorrect model, but it's a useful learning and teaching tool to get a sense of how these things look. Ultimately, the more accurate model of the atom is the electron cloud model and energy level model, quantum model. Anyways, in the Bohr model we have the protons and the neutrons and the nucleus here. And in the first energy level we can hold up to 2 electrons. After that we move to higher energy levels. The next energy level can hold a total of 8. And each successive energy level beyond that can hold 8. And we will not go too far out to D and F sublevels because our Bohr model begins to not really work that well at that point. This Bohr model is going to be really important when we start talking about isotopes and ions, and especially ions, how electrons can be gained or lost, leading to an imbalanced charge of the atom. Let's take a look at carbon. So here's carbon. On the atomic or the periodic table, we can see that the atomic number is 6 and the mass number is 12. So what I'll do is I'll draw out the nucleus, and inside that nucleus I can write that there are 6 protons and there are 6 neutrons in that nucleus. I knew that there were 6 neutrons because the mass number was 12. Remember, mass number minus atomic number gives us the number of neutrons. Also, I know that there are 6 total electrons because the number of electrons is equal also to the atomic number. Now, as we build and draw the Bohr model of this atom, we must remember the first level only holds 2 electrons. That first energy level is full, and then we begin to build into these outer energy levels. And so ultimately I'll have 4 electrons in this outer level, and an important idea is that we call these electrons valence electrons. They're the ones involved in chemical bonding, which we'll be getting into very shortly. And that is a pretty good overview of atomic structure. Let's look at the periodic table now. Okay, so for this class, we're going to be needing to know the first 18 elements on the periodic table. Not memorized, but be familiar with them and how they work, how they like to bond, their atomic structures, and all that good stuff. One of the assignments I'll give you in this unit is to draw the planetary model or the Bohr model for the first 18 elements. So let's go through a couple of these so you get the sense of what I'm asking you to do. Starting with hydrogen. So hydrogen, actually, let's go to a different one. Let's go to oxygen. Okay, so there's 2 numbers on oxygen that you can see here. There is the atomic number, which is this number here, that's the 8. So remember, that tells us there's 8 protons and 8 electrons. And then the mass number is here. Now, this is the atomic mass on this table, 15.9994. And so what that is an average atomic mass of the isotopes. Basically what you need to do is round that to the nearest whole number. So we'll round that to 16, and then the whole number rounded value will be known as the mass number. So the number of neutrons in oxygen would be the mass number 16 minus the atomic number of 8. Well, what do you know? The number of neutrons is also 8. Let's take a look at how I might draw this out. So to draw the planetary model of oxygen, we're going to draw a circle that represents the nucleus. Inside the nucleus, we're going to say P equals and then N equals. And we'll write the number of protons, which was 8, and the number of neutrons, which was 8. Around the nucleus, we'll draw the first energy level. Remember, the first energy level can hold only 2 electrons, so I'll draw those 2 electrons like that. Then we'll go out to the next energy level, and we have to show a total of 8 electrons here. So I'm going to go 1, 2, 3, 4, 5, 6. So you'll see that now I have 6, 7, 8 total electrons. And we'll write the element symbol, oxygen, and that is the planetary model for oxygen. Now where we're going to go with this information in probably next week is how this becomes an ion and creates chemical bonds. But for now, I think this is a pretty good start. Okay, bye-bye.